All right, so welcome to my science experiment for science class. Today we're going to be doing a Cartesian diver. Now before I go through the instructions, I'm just going to give you a bit of background information in case you wanted to teach this lesson yourself. It is in the grade 2 curriculum under Understanding Matter and Energy for properties of liquids and solids. The overall expectation would be number 2, investigate the properties of interactions among liquids and solids. And the specific expectation would be 2.4, use scientific inquiry and experimentation skills to investigate liquids and solids in their terms of their capacity for buoyancy. So this definitely would have to do a lot with sinking and floating, as well as combines a bit of density as well. So one of the key words would be buoyancy, density, which would be one words you'd kind of want to highlight in case you're introducing this as a first term to your kids. For the purpose of this experiment, I'll go through the different things that we'll need. But before we do that, as doing any science experiment, you do need to make sure you take safety precautions. Now, the things we're working with today are not a high-risk situation. But this is something you do want to highlight to your students, that it is important to think about what you're using and what type of things you need to protect yourself with. I always like to use a specific type of eyewear. So in this situation, I'm going to make sure that I don't get any water in my eyes. As well as we are working with water today, so maybe keeping our electronics back a safe distance so as to not get anyone electrocuted or anything like that, or ruin anything as well. Now for this, we're going to be building what we call a Cartesian diver. So the first thing you'll need is a bottle of water full to the top with water. I would recommend using a 1 liter or 500 milliliter. The 500, which is this, has worked the best for me. 2 liter was a bit of a problem. It didn't really squeeze properly when we get to that point. This is definitely an experiment I would try out a few times before you do this for a group of people or for a video like I have done, because it is a trial and error situation. So you've got the water filled to the top. And then you've got to take your pen, a ballpoint pen lid. Now, I would recommend one that only has the hole for the pen, not the hole at the top. I do have a hole at the top, so for this experiment, I've just put clay on both sides. And then, again, like trial and error, you need to figure out whether the amount of clay you're using is enough, because if you put too much, it's going to sink, like you'll see in this one. Or if you put too little, it'll float, and when you squeeze the bottle, which is what we're going to do, it's not going to do what it's supposed to do. Now, I've got a complete project here. Now, some questions you could definitely ask your students before moving forward is, before you put the pen in, you can say, well, what do I have here? Describing the objects that you do have, and then what do they think is going to happen when you put the pen into the water with the clay. Now, when we've done it, this is what it should look like. So the pen, it should be kind of swimming around at the top. If it's too light, it'll kind of sway on the side like a fish that's sick. And if it's too heavy, as we mentioned, it'll go down to the bottom. Now, when you squeeze the bottle, the Cartesian diver will go down. When you let go, the Cartesian diver is going to go up. Now, again, this is something you can ask the students what you think is going to happen, and then you can ask them why they think that's happening as well. With the experiment here, the reason for this happening is because we're dealing with density. So there's an air bubble within the clay in the pen lid. When you squeeze the bottle, it actually compresses and gets smaller, and therefore it's more dense, and there's more water around it, which causes it to sink. When you let go, it then decompresses, and the pen lid goes up. Now, decompressing and compressing may be bigger words as well, so that's something you could highlight on a word board or go over those definitions, or if you have a word wall in your classroom as well. Now, to take this opportunity further as well, you could try it with a soy sauce packet as well. I tried it myself and it didn't work, so I'm not going to do it for this experiment, but that is an experiment you could definitely try with your class. Again, there is the air bubbles within the packet. I'm going to go a little bit closer and let you see what's happening in the diver, which is going down, and then let go. It's going to go up, and you can even try and do it so you've got it kind of a game to try and keep it in the middle, and see what you need to do to kind of keep the Cartesian diver in the middle. Now, the rest, to give another opportunity for the experiment, we're going to take out half of the water and see what happens if I squeeze it. So this is definitely something that you could do to further the learning with them as well and see what you can come up with. So what happens when I squeeze it and what happens when I let go. So as we can see from the experiment, it does the very same thing. Now further as well, you could definitely try different temperatures of the water. And maybe, again, you could try different sizes of the bottle. I just found that this level amount of bottle worked. It's easier to squeeze as well, which if you have children helping you, they're not going to be able to squeeze a 2 liter. Anyways, so that is my science lesson. I hope you've learned a lot today, and I look forward to an exciting school year.